WhatsApp. We are always sharing amongst ourselves. Seeing Dalmas has been sharing about the Starknet. I think it's the winter hackathon that just started. I don't know if it's the winter. So if there's a session, like I know people are just from the Bravos wallet session, someone shares in the group, people jump in. And such. So the Web3 ecosystem is moving at a very, very high speed. And this is one way, at least, for us to meet and exchange ideas and, and align ourselves. And then anyone is open to host a session. Okay, so if for example, like they know Kimathi, you have something you want to share on a project you're working, just reach out. We set up a call, do a poster, then you take it over. So that's the whole point of this. Because if we are, if we're together in that way, we likely will catch on to narratives before they start. And we're able to capture some of that value and such. I know right now there's Farcaster and Frames, the narrative right now. I don't know if there's someone building around Farcaster or apps on Farcaster. I think that's something we can check into. And so someone will build a way for Starknet, for Farcaster to connect to Starknet, something like that. But anyway, that's the idea. We're here tonight for Dalmas to host this episode. And Dalmas launched the Starknet deployer I think a week ago. I saw some guys from Starknet, congratulating him over there. Dalmas looks like a good airdrop might be on your way, and such things, encouraging to see, and even they give us morale to keep building. So Dalmas, take over. However, in what format you think is best. But maybe once you're done, you can come back and people can have a conversation, and then we can move from there. So Dalmas, karibu.
Okay, thank you, Matu. I believe you can hear me.
Yes, loud. Yeah.
Okay, thank you. So today we are going to take a look into Starknet smart contract development and not really into the coding part fully, but rather how we can ship a product right from the code to either testnet or mainnet. So I don't really want to keep people here, so let's just get started. I'll present my screen and we kick in. So first of all, let's start with StarkDeployer. So this is one of the things that I'll be showing you how to use today so that you can be able to quickly have your products ready on mainnet or on testnet. So yeah, let's start where we usually start. That is setting up the smart contract development environment. And that's one part that is critical in any development of anything, be it a game, be it a website, or be it now these smart contracts. So when it comes to Starknet smart contract, a few things need to be set up. That is first, you need to set up your VS Code to be able to handle or to be able to display correctly what you're building or your smart contract. That's the code. And a few more tools to get started with it. So Starknet uses a new language called Cairo. It has not been in existence for long. So Cairo is some copy of Rust. So if you are familiar with Rust, you can say you are familiar with Cairo because not much of Rust has been moved out of Cairo. Everything in Rust is in Cairo, except Cairo has fewer properties or attributes as compared to Rust. So let's see where to get started if you ever wanted to develop a contract and how you can deploy it. So the first tool is called Devnet. So Devnet is like a local node to help you deploy locally. So for testing purposes, it's best that you start with Devnet since it's much faster as compared to deploying maybe to testnet or testing on testnet. And number two, it's having like your own environment that you can move with where you are developing something. So Devnet is the first thing. So this is like a local node. So Starknet Devnet RS, and this is the link. Let me post it here. So how do you set up Devnet? So to set up Devnet is quite easy, not really tough. So you just need to clone this repository and run it offline. So you'll just copy there. Here I'm going to move to a new folder. Then I'm going to open in terminal, then clone it here. So we give it a moment to clone. There we go. So once that one has been cloned to our repo, so if we're less, we can be able to see Starknet Devnet RS. So we are going to move into that folder, and then we are going to run cargo run. So before you do the cargo run command, I think I missed that part. So you need to set up Rust development toolchain. That is installing up Rust and cargo itself. So cargo is like yarn or npm. So it's a package manager for Rust. So that's a thing to install before you get started to installing things to do with Cairo. The other thing that we need to set up or another tool is called Starknet Foundry. So Starknet Foundry is a tool, I believe those who are coming from Ethereum have an idea what a Foundry is. So it's a tool same as that one, but now on Starknet to help you quickly now move around your smart contracts. So let's get to it. So if you search Starknet Foundry, go to this foundry-rs. So let me open it. And we're going to installation. Okay, do we have, so Foundry is easy to install on Mac. Okay, that's installation. So let's just, let me share this. So Foundry is another tool to help you. So it will help you in testing. It will help you in interacting with your contract, and also it will help you in deploying your contract. So that is the first thing is testing. The next thing is testing, declaring, deployment, and interaction. So that's the work of Foundry. So Foundry comes with the two tools. The first tool is called SNCast, and the other tool is called SNForge. So I'll illustrate their use cases. So to install, you just copy that, paste it there. Then once it's up, you need to just copy the next command, that's SN Foundry up. Then paste. So this will install Foundry, the latest version, of course. But if you want to install a given version of that one, you will just get it. Do we have it here? Nope, not really. Okay, you can just test it out. There are always help commands with these CLI tools. So after running cargo run successfully, you'll get a few pre-deployed accounts. For example, a universal deployer contract account. Then we have some pre-deployed fee token, 8 stack, and a given class hash. So you can use this class hash to deploy new accounts or create new accounts. And these are the rest of the accounts. And you will notice it's running on localhost port 5050. So this is another thing. Sometimes you might need to switch this because you have another instance running on port 5050. Yeah, and another thing that we can take care of here is this seed to replicate this account sequence. So this is also critical when you sort of want to reuse the same accounts over and over again without the need of switching accounts. Reason being, or why you could need to save this, is because when you are developing on Starknet, you sort of need to move these accounts to a given file, that's scab.toml file, so that you can use them from there to call or invoke your contract. Sometimes just running cargo run creates new accounts. That means setting up new accounts. I'll illustrate how to set up new accounts as we go on. So we have Foundry app. Starknet Foundry has been successfully installed. So they are giving us some things here. That's a SendForge version, and so just copy that. So we have that one. So 0.16.0. Okay, this is repeating the same thing. Let me confirm whether I have what I had. Yeah, so I have installed Foundry 0.16.0. Also, this is the same with the SNCast. So these are the two tools I was talking about. So SNForge will help us initializing new contracts and also testing, while SNCast will help us in declaring, deploying, and interacting with the contracts and accounts. So let's proceed to the next part, or the next tool. The next tool is called Scab. Scab is another tool to help build, test, and manage our contract. So let's see. Starknet Scab. So okay, documentation. Scab is the Cairo package manager. Scab downloads your Cairo packages, dependencies, compiles your projects, either pure Cairo, and works as an entry point for other tooling work with your code, so such as Starknet Foundry or in other IDs. So Scab is another critical tool. So as Sita said here, it's a Cairo package manager. As I said, Starknet uses Cairo in its smart contract development. The initial version was using Python, but later they started to migrate everything to Rust. That's when I believe they came up, or they decided to come up with their own language, that's Cairo. So how to install this one? So installation, you can follow this link where they have given us a few installation. So you can install using a given script. And also if you want to install a given version, you can easily install that one using this. So let me just copy the first link and paste it there. So while you are setting up your environment, things might crack down or things might go aside, but you don't have to worry much. Just switch versions. For example, the current version I'm going to install, this is version or the latest version of Starknet and the latest version of Scap and Cairo language server. Things might go south, so you might need to downgrade. It's bad to say that, but it's good that you know about it. So it is really giving a lot of developers issues when it comes to just setting up the environment and running something on Starknet. So we have Scab. So we started off with the Devnet, then we went to Starknet Foundry, then we have finished up with Scab. So those are the three tools that you first need at hand. The other tool or the other tools will come into VS Code. So let's create a new project here. So I'm going to cd, okay, cd projects. I need to cd to blockchain, cd Starknet web3. Then there I can create a new folder and cd into projects. Then we are going to use the SNForge tool to create a new project. So SNForge init. So SNForge init with the project name. Otherwise, if you don't know most of these commands, you just do SNForge help, then it will give you a number of things or a number of commands you can use. So we have test to run test, init to initialize a new project, clean cache to just clear some cache directory, and help whatever we have used currently. So we do SNForge init and the project name. So we can call this as maybe call it whichever you call it. So we'll call it first project, cd first project, and I'm going to open this on VS Code. So once you're in VS Code, so let's install the last remaining tools or the last remaining helper things that we require. So that is extensions. And here we're going to install two specific extensions. The first one is called Cairo 1.0. That this one here, Cairo 1.0. Don't install the Cairo. And the next one is called Cairo syntax. So make sure you have Cairo 1.0 extension. There you have 2.3.0. I don't know whether this means the version of Cairo it's using. Then we have Cairo syntax. So this will work hand in hand to help you catch and also give you proper syntax highlighting for Cairo language. So let's see what our contract looks like. By default, when you are creating a new project using SNForge, it will create this sort of directory or files and directories. That is a source folder, test folder, the .ignore file that will just ignore the target folder, and the SNFoundry cache folder. So we'll look more into the target later on. Then we have scap.toml, so like package.json for Node. Now this is scap.toml for, and also like cargo.toml for Rust, etc. So here you can be able to see the dependencies and also some more information about the setting up of the project itself, like the target.starknet contract. This will tell the compiler whether to compile the contract to Cairo assembly or not, and also whether you want Sierra or not. So sometimes you will get it having like something like this. So Sierra is like now the source code that is sent sent on chain or sent or deployed. This is the one that the most platforms use to sort of show your contract, etc. So, but the current versions of Cairo do not require you having Sierra. By default, it will compile Sierra, even if you don't have it here. So also here you set the package name. So first project is because we call our project first project. So, and usually for Rust, the name or most of the values that are here don't usually have like camel case or anything. So usually they require one name or one word, so underscores, not even the dashes. Otherwise this might result into errors or problems. So have it as first project. So in the lib.cairo, what do we have? So here we have the entry point of our project. Lib.cairo is the default entry point for Rust, same for Cairo. So lib.cairo also, okay, for this case it has a few things. So we have something called an interface. That's a trait from this a trait, and also we have a mode decorated with Starknet contract. So this marks the entry point of your contract now. So this contract is called Hello Starknet, and here we have a storage struct, and this is decorated with the storage macro. About this interface, so this is like creating a blueprint of your interface or a blueprint of your functions, how you want them to look like, etc. And here we are going to call the MBL, or we are going to implement the interface so that it can now interact. Okay, so that we can now, it's like building now the contract itself by implementing different interfaces. Not a must for you to use interfaces. You can just simply have functions here, like that, maybe your function, and you can proceed to do what you want to do here with your function, and just decorate it with something called external v0. Yep, like that. So this is going to make this function like visible externally, not a private function. So not everything is external. I believe we can borrow this from the rest of the blockchains that we have worked with. We have private functions and public functions. So if you want your function to be a public function, you have to decorate it with the external. Otherwise, you can leave it like that for it to be a private function, and it's complaining here you have to have this parameter self. Yeah, just start with self here, something like that, then it will stop complaining. Then the rest of the parameters that you want here. Yep, like that. So let me just avoid so let's go. I'll talk more about this, okay, yeah, in a moment, but let's look at the tests. So we already know that without the tests, it means you might be shipping something that's not good, and that's where we use Starknet, a Foundry, a SendForge to be specific, to be able to test out our contract. So it will give us a number of cheat codes, cheat sheets that we can use to interact with our, or to test out our contract. So let's just open the terminal, and here we are going to run the first command, that is a SendForge test. So this is to test out our contract. So currently we have a contract that is just a simple contract, that is a contract that has a single member in the storage struct, that is balance, and it has two functions, that is increase balance and get the balance. So increase balance, it will increase the balance by given value that you pass in, and get balance will just return the balance that has been stored into storage. So when I ran this command, the SendForge tests, it came up with this target folder. So like node, if you run something like a yarn build or npm build, it will either build out the dist, or for next _ next, it will depend on the framework that you're using. So for this one, when you run a SendForge test, it will just build. Then if you just want to just build that target, you just need to run scab build command. So as I said, scab is another package manager. It has this function also to help you build your project. So if you didn't have this target, for example, using scab build will also give you the same result, or the same thing. So this is the one that you'll use before you do deployments, etc. So let's talk about the tests. Currently we can see our tests have passed. So let's talk more about the look of the contract. So you have seen this thing here, hash storage, that is a macro, and this is a struct called storage. By default, every Cairo contract can only have one single storage struct that has been decorated with the storage macro. This will mark everything here to be stored into storage. So that's the first thing that you need to know. And also we have other macros. For example, the other one is called constructor macro. Constructor. So this one can only be used with a constructor function, and this will mark the few things, or the call data. I'm talking about call data, or the few things that you'll need when you are initializing your. Let me just write it completely so that we can be able to. Okay, I have it here. It can create me like that. So let me delete this. Yeah. So the constructor will help us set up a few things when we are initializing our or when we are deploying our contract. For example, we want to set the admin. You can't really hard code such a value. Contract address. You don't really want to hard code an admin directly when you are sending out this the contract, because most of these contracts are open source and you don't want to show who is the admin. And maybe even something like a fee, maybe you have a fee that you are charging for something in your contract. Maybe you have some other, maybe guardians. You don't want to show who the guardians are. So you might decide to hide these values as you go on. So some things like this can be taken into the constructor itself. So for example, here we can have the admin, contract address, and we also have what's this, the guardians, or guardian 1, guardian 2, guardian 3. So you can have all those somewhere. So let me import contract address. Yeah, so that's the thing. So here I can just quickly do self.admin.write, and I'm going to write here the admin. That's the admin. So when you are initializing your or deploying your contract, that information that you want to hide for security purposes, you use a constructor to do so. So let me just delete this because I was just illustrating it. Then I continue giving more information about this. The next part is this called events. Also, like the storage struct, you can only have one event struct decorated with this set event. Okay, event must be an, oh, this should be an inner. Yeah, Starknet event. Yeah, so let me just finish that. Unsupported event must be hash event. Yep, then hash event. I have no idea where I'm getting several of these problems, but yeah, we'll walk through them. So when you are having events for your contract, you can only have a single event. Maybe this event is called, let me call this increased balance event, which is of type increased balance. And these events are always struct. So you need to do struct like that, then proceed with that. And all the events are always decorated with the, let me take this here. And why am I getting that? Okay, I need to, I think, hash derive Starknet event like that. I think that's where I'm doing it wrong. Yep. I have no idea why I'm getting this, but you will learn more about this with some resources. So you have to decorate your struct with Starknet event besides the so-called drop copy macros. So this part of the things that when you go into development, you will learn more or you will encounter. So that's another thing that you will need to take into consideration. And we also have this hash API embed v0 macro. It also works like external v0. I think this is for the newer versions of Cairo, and I think it changes almost daily. So sometimes things work well, sometimes things go south. Yeah, so this one will also expose the entire interface. So that is including its functions for to the public. So I think I've talked a bit about this one. So let's talk about testing the contract. So in testing, first you'll notice we have SNForge is good enough to come up with a simple testing or a way for you to test out your contract. So it will set you or give you the initial settings. So we have the deploy contract function. So this is just a function to help return the contract address so that you can use that contract address to now run the methods. So here we have the declare cheat code. This one is given by SendForge. So it will help you declare your contract. Then if you have now, once you have declared your contract, it will return some value that has the deploy method on it. So you can just do contract.deploy, and this value here, the @array trait new, this is the constructor information. So let's say you wanted to pass in the admin. So let me just do let mute constructor call data equals to that. I can't really do at here. So you have an array like this, then you just need to push in the information as it is. So you just do constructor call data dot append, and I'm going to append the new address for the admin. So it might be something like a 0x and some information. Then I'm going to pass in the a copy of this array trait. So copies in Cairo are called snapshots, if I may use similar terms. So using the at means you are just sort of taking a snapshot or a copy of whatever is here. So we use snapshots for constructors when we are deploying. So contract.deploy will return a contract address. So let's look at the first function, test increase balance. If we look at the increase balance function here, by default, it will first assert and make sure that the amount is not equal to 0. And then it will proceed. Then we have self.balance.write, self.balance.read plus the amount. Yeah, I think I missed this one here. So when writing something to the storage struct, you just use the write method. And when reading the value, you use the read method. So and in this increase balance method, we are just going to do self.balance.write. Then we read the old value. Then we increment it by the new value. Then we save it to the balance member of this storage struct. So looking at this test here, you'll notice that we have deploy contract. So it will take in the contract name. The contract name usually comes from there, so don't struggle looking for it. And if you change this one, remember to change it in all its appearances. So hello Starknet is our contract. So take in the contract name, then you will get something called a dispatcher that you need to import a few more things from the contract itself. That's a hello Starknet dispatcher. So this will sort of return an interface with all the functions. Those are usually public functions that you can use now to interact with or call your contract. So that's called a dispatcher. So it will return like an object containing all the functions. From others.js, you will notice we have something like a contract. So usually you do something like new contract, then pass in the ABI and etc. So it's sort of doing that, the exact thing here. So we have deployed the contract, we have the contract address, so we just do sort of initialize a new contract here. So that's the dispatcher. So from the dispatcher, we can call the other methods, that is get balance or increase balance. So by default, the increase balance will try to assert the balance before was 0, then increase balance by 42 and assert whether the balance was increased to 42. So it's because 0 plus 42 equals to 42. Otherwise fail. Same goes with the test cannot increase balance with 0. So this testing whether you can increase a balance with 0. And for that, you need to sort of use a match to check the value that was given out. So let's see what we have here. So here it says amount should not be 0. That's the panic statement. Of course, that's what you get here. Amount cannot be 0 because that's the panic statement. So they're reading a panic data at index 0. So this panic data is an array. So this is the match statement. If you are familiar with match statements from Rust, it's similar with the case statement in other languages. Also, I think there's a case in Rust. I'm not sure. Yeah. So for JavaScript, the case, or for Java, the case statement. So where you just check for different cases. So equally here, it's trying to check for different cases. And if this, so it will get to this value here at the end of the day. So save dispatcher will help this save dispatcher macro will help this block of code not to just fail, because by default it just fails. If you get rid of this, it will just sort of crash or not really done the thing. Send for test is the command. So it will sort of fail because it has panicked while it's running. So to avoid panic while it's running, that's why we decorate it with safe dispatcher. So this code here will use the safe dispatcher not to panic at that particular point, and also the same here for us to be able to now just quickly check for this panic statement from our contract itself. So that's much about contract development and testing. there's more into this if you venture into it. Any questions? Okay, so I don't know if there are any questions. Maybe post them into the meeting link. Okay, yeah. So if you have any questions, you can post them as we go on. So let's go to the next part. How do we deploy our contract? How we declare. That is, when deploying, we need to start off by declaring the contract itself. It's like now sending out the Sierra source code, that is the contract source code, onto the server, then storing it and getting back a class hash. So a class hash is like an ID to identify the source code where it is stored on chain. So that's why we use declaring. So move the code on chain. When you are deploying, you only deploy just a class hash. So I'll show you what the class hash is as we go on. That's the next part, of course. So where do we get started? So I'll just call here scab clean. So the work of scab clean is to get rid of the target folder, and usually it's a good idea to just clean your project and also to get rid of any cache so that you can now build a clean slate that you are going to deploy. So we have built. So let's look at the target folder once more. In the target folder, you notice we have a dev folder. In this dev folder, we have 3 files currently. Sometimes there might be more files than 3. Reason being, let's say you have more than one contract, because you can build more than one contract when you are building. You'll have more than, so each contract will have like 3 files. So if you have 2 contracts, expect 6 files in the dev folder. So how do you know your contract? You just look at the contract name. Hello Starknet will be appearing in the contracts in these 2 files. And here you'll notice we have a file called compiled something hello Starknet, then compiled underscore contract underscore class.json. So this is the, yeah. So this one is the Cairo assembly code, and the other one, contract underscore class, is the Sierra contract, the Sierra code. So this Sierra code also contains the ABI. So if you want to get the ABI quickly, maybe for now doing the front end, you just need to copy from there up to there. You don't have to copy everything. You only need that ABI part. So it only contains 2 functions. So let me show you the ABI here, JSON. Okay, I think I can have this JSON online. JSON online, I don't know, is this one? Still this one? Yeah, let's use this one. I think it can work. So it does not have a formatting thing. Let me do it using VS Code. So just come here, create a new file, abi.json, format this one, and let's look at it. So this ABI is the same ABI that we are used from the ETH contracts. So it has the implementations, that's an MBL, and we also have the interfaces. And if you have a type interface or you add in an interface, then that interface will have the functions, the different functions that your contract had, and any of the events that you had, they'll also be appearing somewhere there. So that's the ABI that you'll get from this file. Then the custom file, usually this one we don't get anything, but it will help in declaring and deploying the contract itself, because it's now, this is the one containing like the source code itself of what the contract or the contract commands and things of sort. So finally we have this symbol file here called first project starknet underscore artifacts.json file. So this will contain the different contracts that you had in your source file or in your source folder there. So the first contract here, it will show you the contract name and the artifacts, the Sierra file and the Kasim file. So I believe we are good to go to declaration. So how do we declare a contract? So we are going to use SNCast. That's the other tool besides SNForge given by Starknet Foundry. And SNCast is going to help us very much in most of the part. That is, it will help us to declare, deploy, call the contract, invoke, even perform a multi-call, interact with accounts. Okay, and the rest of this information, these are, I think, the helper information. But the first few commands are the most critical commands that we need with the sendcast. So how do you use a tool, for example, declare, or the command declare? Usually getting this information is tough, so just pass in a sendcast declare. Can I move this up? So just do a sendcast declare, then pass in the help flag. So the declare command with the help flag will give you what you need to do. So a sendcast declare some values there. So a sendcast itself has a few more other options that you need to pass in, more flags that you can use. Also take this into account because you will need them much besides these other regular commands there. So the profile flag, the URL flag, the account flag, the keystore flag, and the rest of the flags here are very important. So let's just deploy our contract. So by starting off by declaring. So the first thing we are going to do is to add an account that we are going to use now. So a sendcast account dash help. It will help us. It has a few commands: add, create, deploy, delete. So the command we are going to use for now is called the add command. So I'm also going to do like that. So this will help us add a new account directly into scark.toml file somewhere here, so that we can use it to deploy, declare, deploy, call, and invoke our contract. So the add command takes in a few things: the name of the new account you are adding, the address, the class hash of the account, the whether it is been deployed or not, the private key, the public key, the salt, and add profile flag. So this add profile flag, if passed, a profile with corresponding data will be created in scark.toml. So this will help us add the account direct to scark.toml. So a sendcast or a Starknet Foundry uses the OpenZeppelin way of keeping accounts or of creating accounts. So maybe I'll just do one and show you how it goes. So I'm writing in the wrong file. Not there. So let's first do that. A sendcast. I'm going to use a flag called here URL to add in the RPC endpoint URL. So which is http localhost port 5050 /RPC. So you can do /RPC or local 50 like that. There's no harm. Reason being, Starknet Devnet exposes both RPC and 5050 as the default entry points of these RPC calls. So let's look at this Devnet. So when we were running Devnet, whenever you are developing, you need to have Devnet always running. Maybe not a must, but you need to have it running for declaration, deploying, interacting locally with your contract. So that's why I have it here. So once I have done that, I'm going to call the account command, then the add command, and in this case I'm going to pass in the name of the account, and this one, let's call it a web3 account, like that. And the next thing we are going to pass in is the address of the account, and the address, you can get one of the addresses. Here you have been given 10 of these accounts, so just pick any, like that, paste it there. And the next thing it wants is the private key, and in the private key you are going to copy the same from the account that you took. Take the private key, so I'm going to take that one. And finally we have the public key, so public key, and in this case I'm going to copy the public key here, like that. So that's the initial information. The next I'm just going to call the add profile flag to add this onto stark.toml file. So let me save this file first and hit enter. So you will notice it has done something here. It has added a new tool for SNcast, and SNcast is also very critical by adding these tools. For example, this tool.sncast, it has added an account for us here. It's also critical when you are forking Goeli testnet. Let's say you have a contract that includes sending and receiving tokens. How can you do that one? How can you do that one when you are testing? Because critically speaking, testing is very, very, very important. So if you want to test out sending out maybe USDC on testnet, DAI on testnet, or any other token on testnet, then SNcast is the tool to help you do that. I'm not going to talk about that one because that's sort of more in depth, but you just fork Goeli testnet, and after forking Goeli testnet, you can immediately send out USDC, receive USDC to your contract, to your account, etc. So we have added a new account to stark.toml file. So the next command is now declaring the contract. So SNcast, I'm going to call the declare command with the help flag. So let's see what we have. It will always ask us for the contract name. So let's do that. So SNcast declare -- contract name, and our contract name, always just get the contract name from there. That is, yeah. So currently it's okay, declare contract name here. Okay, so we are having some error here, unexpected argument here, contract name. I think I misspelled. This should be contract name. So if you try to do that one, you will get an error saying RPC URL not passed in stark.toml or nor found in stark.toml. So when it says like this, there are two solutions to this. You can do something like this. You pass in the URL here, as I did, using the URL flag. So I've just used the shorter version of that one. So you do HTTP localhost port 5050 RPC like that. This one will try to do something, but it's still complaining account name not passed. So this is where you sort of just you can avoid doing all this. Or let me just do the command again. Yeah. Okay. Why is it? Let me just delete it completely. Okay, I'm not getting what I really want. Let me just pass it back. So -u HTTP like that, localhost port 5050/RPC. Then the next thing you need to pass in is the account. So you can just do -- account, and you pass in the account name that you have used here. So like that, then hit enter. So this sort of going to compile, do everything again, and then it will return two things from here. The first thing is the class hash. So class hash is always returned if there is, and a transaction hash. Sometimes it might return the transaction hash if this is a new contract being declared. Otherwise, it might only be returning the class hash with an empty transaction hash. So that's one way of declaring. We have just passed in here the URL and the account that we're going to use to declare. And sometimes you don't have this luxury of doing all this, so you can avoid doing all this and make a default account in your stark.toml file. So how do you make an account to be a default account? So maybe you have several accounts, so you can just delete one of them like that and have that one as the default account. So if I do that and delete like those ones, so this one is also going to use this one. So this one is going to use this account as the default account. So we are getting an error here that says declare failed because the contract has already been declared. It's already declared. That's an error. So that's why I said sometimes it can return both the class hash and the transaction hash. by default. Okay, for this case it has just panicked out and says, and they are given us an error, but we have the class hash. So we are going to use the class hash to deploy our contract. So we copy the class hash like that. Then let's just clear this and run the next command. So the next command is called the deploy command. So doing like that is going to ask us for the class hash. Otherwise, the short version of it is -g. And the other critical information is the constructor call data. If you do recall, I was talking about a constructor. That's where you need a constructor to, that's like you need a constructor to initialize your contract. So you use the -c flag to pass in the values. So how can we use this? So I'm going to do a SNCast deploy. Because we already have a default account, I don't have to worry about the account and the URL. So I'm going to deploy, okay, I'm not typing the right place. So here I'm going to do maybe -g with the class hash. And if you had the constructor call data, so how do you pass in the constructor call data? Let's say you had param1 admin, param2 guardians, param3, etc, etc. So you need to pass in the way they appear. So param1 was admin, so you just pass in the hex value of the admin, 0x admin address, do a space, then pass in the next value, pass in the next value, then hit enter. So for this case, we don't have like that. So let me delete this and paste it afresh. We don't have a constructor, so we don't need it. So hit enter. So this one is going to deploy our contract. And at the end of the day, it's going to return a contract address and the transaction hash. One thing to take care of is the contract address. So just copy that one and put somewhere like that. So we already have that one secured. So the next command is, how do we interact now with our contract? Our contract currently has two functions. That is the, okay, we have two functions here, the increase balance function and the get balance function. Yeah, so you might be getting such like errors where you are doing your work, right? So this might be as a result of Cairo language server. So it might force you to just shut down your extensions and reactivate them again. So for now, I'm not going to do that. I'm just going to do that like that. Okay, let me just minimize this. Where are you? Like that. So we have increase balance method and the get balance method. But something else to take into consideration here. Whenever your method has a right use or the dot right use somewhere within it, it's no longer just a read method. Now that's a write method. So this increase balance function is a write method. And for this case, if it's a write method, you'll notice it's now using like a reference to the contract state, while read methods like this one dot read just uses self a snapshot, just a copy, because you don't want to just use a ref when you just want to read. There's no need. So, and that one might cause or might invoke your wallet to just consider this function a write method, because the source code is already sent somewhere on chain. So avoid using refs when you are just supposed to use snapshots, to avoid somebody being or paying for gas fee whenever they're not supposed to pay for. So that's why we have self at contract set, like just a copy of the contract state, and ref self, just a reference to the exact object of the contract state. So that's why we have the difference in ref and the at thing. So let's try to read the method or read the balance of our contract and see what we get. So walk right into the terminal, clear it, and let me increase it like that. I believe it's visible, or yeah, this one's not better. Can I clear? Not even visible to me. Yeah, I think plus, okay, it's hiding it. So let's do a SNCast help again. So if you call this command like this, you'll notice it's giving you a lot of things. So we are currently going to the call command, then later we are going to use the invoke command. I'm not going to use the multi-call command. That will be your assignment. So let's use the, yes, is that a question, or let me check it. Welcome, Harriet. So let's quickly go here so that we can invoke it. SNCast call, and whenever you are calling, you need to pass in the contract address. So if I do help here, you will notice something like it's asking us for the contract address and the function. So A, F, and N call data that we're going to use. So I'm going to do a SNCast call. The address, do I have it here? Yeah, the address. Then the function that we want to call is the so-called get balance function, get underscore balance function. So, okay, it seems I have some error in my code. Where is it? Yeah, this is part of the problems, but you have to endure them till the end. So let me look at the terminal. It's saying caused by exited scarp doesn't exist in manifest file does in the current directories. But it is there. What is causing this other error that I'm getting here in the output? Request document text failed. So this one is caused by something that I don't see. Line 20. Okay, maybe I missed something. Oh yeah, this thing here might be the problem. So let me get rid of it from there. And I believe I'm good to go. Yeah, let's try to call it again. Yeah, so yeah, that was my error. I pasted the address here and I never remembered to avoid saving it. So if you now do a SNCast call, you'll realize it's giving you the command type, that's call command, and the response is 0x0. So this is another thing that might shock you away, but nothing much to fear. So 0x0, it does not return values as 0 because the balance is 0. It usually returns values as hexadecimals. So you will need to convert them back to decimals for you to be able to read. So let's just invoke the increase balance method, then see what we get. So I'm going to actually, the method here is increase balance, and we are going to increase this by 42. And okay, I need to do like -c. I need to change this one from call to invoke, like that. Yeah, so if you invoke a function, even if you had something being returned from that function, it does not give you the return value. It will only return a transaction hash. That's, I think, the nature of write methods. They will only return the transaction hash, not the value that you returned from the write method. So if we call the other method the increase balance, you'll notice it has given us 0x to a as the response. So I'm going to copy this, use some tools online. And the tool we are going to use in this case is hex to decimal. You can search use tool. For this case, is just for testing purposes. This is not what you are going to do when you are going to work on your project. That's on your front end. So for your front end, there are tools already given by Starknet SDK. That's Starknet JS to convert these values from hex to decimals, decimal to hex, etc. Decimals to felts, etc. So we have gotten the right value there. So if we increase this by 10 and get the balance, so 0x34. So for that one, we can do 34 and the result will be 52. 42 plus 10, 52. So don't worry about these hex values here. So yeah, this is part of the things that I believe are inbuilt to this Starknet for security purposes. Not displaying the exact result, but for Starknet explorers, that is StarkScan and the Voyager, they just display the values that you expect. Of course, the decimals included and the readable, human readable values as you expect. So this is the farthest we can go with declaring, deploying, calling and invoking our functions. So one last part remaining, so we call it a day. Any questions so far? If you have a question, you can post it or unmute, speak it out. Yep. So the next part is the first part that we started with. That is, how do we use StarkDeployer? So this is like a better version of StarkDeployer. There's another version being worked on with a few more team members to help us now have like this desktop application or a desktop application for both Linux, Windows, and Mac OS. That is to help us. Yes. Is the session being recorded? Yeah. I don't know whether Alex is having some other recording.
It should be recorded by Jim.
Yeah, but yes, the session is being recorded. I do have a copy here in case Ochieng is not having it up, but I believe he has some copy. So the StarkDeployer is now we have done some commands here to deploy our contract, including adding an account to scap.toml, declaring the contract, then deploying the contract itself. So that part is quite easy for those who are used to it. But for those who are not used to it, or not even those who are used to it, because even if you are used to it, sometimes these things come up with several errors. Let me just say that for free because you will get them so that you don't be scared away. So you might encounter errors when you are trying to do all those things, like adding an account, creating an account, or using these CLI tools. So we opted to create a tool that's sort of universal that can help you quickly do that. So for testnet, mainnet, all those things, you have to do all the stuff that we did. And in fact, Starknet Foundry is very helpful and it has helped us very much. There was another version or another tool called Starknet. I've not talked about it because, I didn't want to introduce it. Starknet is another tool that can do all those things that Starknet Foundry does. That is the tools given by Zencast and tools given by SNForge. But this one is more complicated, complex, and has a longer learning curve. I'd done some blog about it, so maybe I can show you why I didn't want to introduce Starkly. So Cairo language server, is it this one? Yeah, so this one is done by Starkly, and how you do it is that so Starkly, like SNCast or SNForge, has these commands and flags that you can use. But for this one, for example, creating an account, so let me just scroll down when you are deploying to local development node. By then I was using Katana. Katana is like Devnet, but it's also a sequencer or a node. Katana is a sequencer, so it can also be used in development purposes. So this is the first one that we were used to. So for it, you have to come in and do like do this part where you Starklet declare. You can see you have to pass in the path to Sierra.json file, and also pass in the path to the compiler version, pass in the account, pass in the key store, and to create this key store and stuff, you have to sort of use this other initial part up here where you declare or your key store or your accounts and etc. So it had some learning curve and it made things tough till Foundry was up. Foundry came to avoid all this stuff. So Starklet invoke contract address, the method, the arguments, and all those information. You can see how long this command can be sometimes. So that's where Zencast came in. But now, as a project that we were working on, so we decided to come up with StarkDeployer to avoid all those stuff and just have something that you can work with. For this case, I'm going to illustrate the Devnet part, then I'll illustrate the other part, the testnet part. Mainnet, you can test it out. So let's see what we have here. So when you land into the let me share this link for those who might be testing it out. Yeah, there we go. So the link is stark-deployer.vassal.app. It will be updated later to now production ready. So this beta version things, that's what they look on Vassal. So how do you, so when you land into the devnet portion of this StarkDeployer, you will notice we have a dashboard and it has a few instructions here. So take care of this because it might not seem what we have been working on, it might not look the same. So it has something else. So for this case, I had to share my devnet, the devnet version that I'm using, so that it can be helpful. Since I had some tests with one of our friends here, that is Ken Komu and Timothy Agevi, where we were trying to use the existing devnet version given by Starknet itself. So I realized I'd downloaded some version of Starknet devnet that can work with what I was working on here. So I had to create a repo for that. So just copy this new link and create it. Let me shut down this one. So I'm going to cd back, cd up to there. Okay, I need to go into web3 like that. Then here I'm going to create a new directory. I'm going to, not really, is it a master directory? No. So I'm going to just clone it here. So just paste that one there. It's going to clone me a new devnet version. If I list or list what I have here, I'm going to cd into devnet something rest for StarkDeployer. So here I'm going to run the other command, cargo run command. So while this is doing so you might give it some time to be able to finish it. I believe mine is going faster because of cache on the machine. I don't know, something of sort. So there's another thing here. So we have done that one. We were supposed to export, but I didn't. We'll get to this command in a moment. So what is the importance of using devnet while it's doing its stuff? So devnet gives you the ability to interact with your contract in real time. So all those functions that you had for your contract, you can interact with them here on devnet. Same with the other part on testnet or on mainnet. So that's the one thing that devnet has. It's sort of similar to what we have in Voyager or what we have in StarkScan. So Voyager and StarkScan are the two explorers currently on Starknet. So if you go here, you go to Goeli, maybe Goeli or main, whichever where you go to. So you can switch to any of these testnet or Spolia. So here you can interact with your contract. I don't know whether I have a contract. Let's see. Is this deploy account, deploy account? So all these are sort of deploy account. Let's look at the invoke function. We see whether there's a contract associated with this. Okay. Okay, we'll deploy ours and see whether there's a function associated with it. So let's see what we have. So this one is complaining, saying we don't have Starknet version on the environment. So that's why I said the step 3 also critical. So just export these two things. That's the RPC spec version and Starknet version. So after exporting them like that, then just do cargo run again. So it's just going to run it again, but now it won't fail. It will just proceed to running. The reason as to why we are using a different version of devnet to do all this is because the current version given on the main branch fails. So the rest of the branches on yes, on another call, how Pandulmas. Okay, no problem. So here we are using this current version because with this version now you can be able to quickly interact with your contract without problems. unlike the rest of the Devnet versions. So that's why I decided to have it here. So I believe this one is running. Yes, it's up. So what do we need here? So nothing much. So in this, it has a few tabs. So we have the dashboard tab that we are currently on. The next part, we have the deployments. These are the deployments that you have done. The next part is deploying a new contract. This is the accounts that are currently on the current running instance of Devnet, and the settings will contain more information about setting up. Let's say you want to change the port that you want to connect to, maybe changing the other stuff. Yeah, so let's just look at the deploy, then we'll look at the deployments. So here I'm going to say the contract here we are dealing with is Hello Starknet, and the casting file you can see is contract.compiled contract class. So I need to select that one. So I'm going to go back to the right place. I'm going to project, first project, I'm going to target, and here in dev I'm going to select the compiled underscore contract class. Then select the contract class, that is contract underscore class. Then I hit declare. So I think bugs are starting to shout. Yep, them shouting here. Let me just reload this and see what will happen. I believe this is different. Let me try to do it again. Yeah, when you don't have the right version of Devnet running, it will result into this. So let me rename this to Hello Starknet, then declare. Yeah, so this one has declared, and you will notice it has given us the class hash and the transaction hash. So that's what it does. Sometimes it will provide the two. That's when you are doing a new declaration. If you are doing an existing declaration, it will only return the class hash, no transaction hash. So if I hit declare again, you will notice it has only returned class hash, no transaction hash, because it's not like a new declaration, just it's the same thing, no code has changed. So because it will just go look at the Sierra code, look at the custom file or the Cairo assembly code. If nothing has changed, then you return the same class hash because it's the same thing. There's no need to redeclare. So once you have declared, then you hit deploy. So deploy is going to deploy your contract onto Devnet. So this is the same procedure for testnet and mainnet. So we'll get to testnet in a bit. So we give it just a few. Yeah, so don't worry why it takes long. As much as I said, it's on Devnet or local node. Reason being, it is interacting from the SDK itself to the backend. So once that one has been deployed successfully, it will just clear the form or reset the form so that you can't declare without these two. Then it will return some value. These ones will disappear when things when we'll get to production level. No need for us having this, but it's good to have them for development. So once you have declared your contract, you'll notice here it has been added here, and the only one way you can notice whether it has been added, look at the date and also look at the name. So sometimes you might be having the same name, so look at the date, because this date contains also the time. So you can be able to say, okay, I started at this is the time. Yeah. And it has written here found, and the two of them are not found. Why is this so? So when you are starting a new instance of Devnet, it clears, it's like a new slate of everything. So it generates new accounts, it does not contain the old contracts, etc. So that's why this one has been found on the current instance. The rest are not found, so you cannot really interact with this. But there's a way to curb this with the local Devnet. Where you deploy your contracts yesterday, you come and continue interacting with them today. I'll show you that one in a moment. But for now, let's just click on on interact. So if you click there, you'll notice now you have your contract address. So if you wanted to move this on your front end, you can move it. Just copy this one and continue using it. Also, so these are all the function calls. We have the ABI here. That's the next critical thing. So when you are creating a new contract on your front end, you will need the API and also you will need the contract address. So you just get them from this. So you can copy this, just use the copy button. Same with the contract address, use the copy button, move. So let's look at the get balance method. So if I call this method, you'll notice it has just returned this 0, and I can be able to see the result or error. And the result returned is a big int. So this is another thing. Cairo SDK now here, it will return some things in hex format, others in big int format, but generally the big int I think is the format. Yeah, it will return the results in big int. So for this case, it has just returned a big int 0. So let me just close that one. Let's go to the increase balance method. So here, if you use this platform, this is another advantage on Devnet, specifically on Devnet. Reason being, Voyager has the other stuff on testnet and on mainnet. So here, let's increase this balance by 10 and make the call. So this one is going to sign this value behind the scenes and send it to, send it. So it has returned the transaction hash. So let's look at the get balance. So if now we call this one, it will return an A. Don't worry about the A, just look at it as 10. So that's a big int of 10. For those who are familiar with the hex, 10 is A. I believe so. Yeah, so we can also increase the balance again by maybe, let's increase by 1. We look, the value should be 11. So get balance now, if I make the call, I have a B. So that is the 11 that we have there in big int format. So Starknet provides a way of interacting or converting these to human readable values. So big int, so me, for my case, I just serialized the entire value because I couldn't figure it out. Yes. Yeah, so this is another way to test out your contract. So if you use StarkDeployer, you have to use a different version of Devnet to test out. But the good thing with this, you can notice, is a UI for UI in your functions, and also it makes things easier. You don't have to run all those commands on the terminal for you to have a contract deployed onto Devnet. So yes. Okay, so I don't know if somebody has a question. Right. So the next part is, how can we be able to persist the data here? So I want to have this contract up and running today, tomorrow, and the other day coming. So that is where Devnet comes, some other commands in Devnet comes into play. And if you look at the command that we just used here, is just cargo run. But there are more other flags that we can use in order to attain what we really want. So those commands are as follows. So let me go to my Devnet, Devnet arrest for this. Then I'm going to open in terminal. No, not really. I'm going to just create a new folder here. So it's called dumping data. So it's like dumping when exiting, etc. So let's have the dumps there. Let's open the readme and look at its values, or how we should dump the data. So I'm going to use some other tool here, Markdown, open preview on the side. Then I'm just going to close all this other stuff. And I don't need this. I can close them. So in this specific part, they're giving us ways of loading, dumping data, etc. So how do we dump data? So to preserve your Devnet instance for future use, these are the options. So the first thing is you just say dump on exit. Okay, the dump on command is the when do you want to dump, on exit or on every transaction. I think those are the two given functions that once you hit Control C, that's the command of exiting, or you shut, then when you hit Control C, then when or at what instance do you want to dump? So dump on exit or dump on every transaction. So we have dump on each transaction or dump on exit. Okay, where do I have this? Okay, yeah. So those are the two options. When do you want to dump? Then you have to pass in the dump path. So that's dumping. What about loading? Dumping on request also is there. So I think this is the command. I'm not familiar with this. I've not really used it. I've only used the first two. The other thing after dumping, you need to load your instance. So once you have dumped, load the instance. So to load cargo run dash there, you pass in the dump path. I think this value is this thing has not been given the right path. This should be load path, not the dump path. Did I write this? No. So you need to use the load path flag, not the dump path flag. So you use both of them, dump path and load path. Reason being, you want to dump at a given path and load from that given path. Usually you don't load a path that does not exist. That's why by default you start by dumping. Then later on you have the dump and the load together. So I think this one needs to be adjusted. Yeah. So somebody who wants to do a contribution, let me confirm whether that one has been adjusted. You can contribute. That's another thing you need to recall about Starknet. Contributions pay. So don't forget that one. So Starknet Devnet rs. So let's look at dumping and loading. Control find. Yeah, in fact, somebody can edit this readme and change this from or not just change, but add the load path thing there. So for the one who wants to have a contribution, remember they are part of the airdrops. So just do this contribution on this repo. Let me just share it. Add that path and explain your contribution. Say adding the load path thing for visibility purposes. So here we go. There you have it. So just hit there and quickly just pick it right now and do the contribution. Yeah, because that's an error. Somebody trying to use this tool and gets to that part, they might fail to notice it. So let's dump and load something. So I'll just copy this command as it is. So how does this work? So the only thing here I'm not sure for now, we'll just test it out with you here. Just a moment. Is the path file, whether it should be a file without an extension or a folder. We'll just confirm that one. I have to jump out as well. Okay, no worries. So let's do that quickly. So I'm going to shut down this. I'm going to do dump on exit, and the dump path I'm going to do is from here where we are. I want to use the dumps slash resolve this. Okay, so let's have that one. Dumps. I'm not sure. Somebody can help me here. Whoever was dumped anything. Is it a file or a folder? I'm not sure, but we'll just try it out. So that's the path. Let's run this thing like that. I failed to deserialize that thing. Yep. So I'm going to do dumps slash let's call this hello Starknet. Yes. Yeah, you need to pass in a file at the end. So that's that thing of a file. So now that we have that one, we can just now deploy a new contract. So if I reload this page, you'll notice now this one is not found, it's no longer there. And these are the failed contracts, I believe, sometime back. No, not really failed. I was reloading the wrong thing. Let's deploy it again. Hello Starknet new, and I pass in the path or the compiled custom file and also the contract class, then hit declare, then hit deploy. So it will just, because it was the same thing, just taking short time in declaring. So we give it a moment to deploy, because every deployment creates a new contract address. But also there's another thing you can do to your contract to avoid having different contract addresses for your contract. That's called writing upgradable contracts. So if we look at the contract here, now we have our hello new Starknet. We can quickly now get the balance here, or we can just increase the balance by 10. That one works. So get balance, we have our 10 here. There's no harm. So we have done that one, but let's just sort of shut down the server and see whether we'll be able to get our contract. So if I shut down the server like that, I'm going to do that dump on exit, but I'm also going to pass in the load path like this. And the load path, of course, is // the dumps / starknet something. Oh, it's hello starknet, like that. That's one thing you need to do. And the next thing you need to pass in is, you don't really want to generate new accounts. Let's say your dumping was associated with different accounts, or your contract was associated, or an admin of a given contract was associated with a given account. So how do you get the old existing accounts? To get them, you also use the seed flag. So copy the seed flag and also pass it here, do seed like that. So you have the seed there like that. So to load the old accounts or the existing the accounts, etc. But at the same time, when you are dumping, it will come back with the accounts, I believe. I'm not sure. Let's see. So load path, load found. Unexpected argument found, load path. Yeah, this is a problem. I have no idea what it is, but let's see. So
search for.
Yes. Somebody's saying something.
Sorry. It's search for, and then the account.
Search for, then the account.
Yeah, try that.
I'm not getting what you're saying. Clearly, that is maybe if you can type the flags the way they should appear, or I shouldn't be having the load path here. I'm not sure. Let me see. Okay, let me get rid of this. Maybe I'm having things that are not, account balance is not enough to cover the transaction cost. Okay, pass in the seed. Okay, this one seems to work. So let's see. Let me reload this page. Yeah, okay. Thank you for highlighting that. So yeah, I think I'd used the other version. So yeah, the Python version, you had to add the load path flag, but this one seems you don't really have to do that. Yeah, so let's see, what balance is this? 10. Increase the balance to by that. Did that one run? Not really. Okay, here it is. So let's get balance. So we have our 12, we shut it down. And why is this thing not shutting down? I'm not sure. It is sort of hanging in the air. So yeah, that's the thing. So you dump, and that's how to load. So whoever is making the contribution, don't add the load thing, just add the seed, because without the seed, then means like something like here might be having some issue. Where is it? Yeah, so if you saw the error, it was saying account balance not enough to cover something. So just add the seed to solve that one. Where was that error? Yeah, account balance not enough to cover the transaction cost. Maybe now with the seed flag, it can help that. And another thing to remember when making this or running with different flags, not just cargo run, remember to have the dash dash before doing the rest of the rest of the commands and flags ahead. Otherwise, it will just give you some weird errors. Yeah. So how do you write? Yeah. Any questions so far up to that point? How to use the Devnet platform? Okay. So the next part is writing upgradable contracts. I think that's an added advantage. So how do you write upgradable contracts? So upgradable contracts are also very critical because you don't really want to change the contract address every time. So best that you write an upgradable contract. So let me share this link. This is Starknet by example Voyager. So these are Voyager examples given by Voyager. So different examples, different implementations of different things, including events, etc. Components, that's another thing that I didn't talk about. So let me just paste it here. So you can look at that to learn more in developing nice contracts on Starknet. So we have upgradable contracts here. That's the thing that we want. So to write an upgradable contract, you need to have something like this. The first thing is an interface. As I said, it's not a must, but just arrange your work in this way. Just have an interface for this upgradable contract. Then the next thing you need to have is a few things. So why can't we do that one? So we just copy that one and go to our contract since it's open here. So I pasted that interface somewhere there. So it's saying class hash not found. We can import this one quickly from Starknet. Use Starknet. Is it class hash? Yep. So import it from there. Then the next thing is now more imports. So we have the class hash import here also, and we have a few things. Syscall result core. Just have this because without this one, things are going to look weird for you. So have them maybe below your imports or somewhere, just within your mod or between that's your module, the contract module, and yeah, the contract module decorated with the Starknet contract thing macro. Have those there. Then you need to implement the interface. So copy this. There's nothing heavy about this one, so have it there. So it's going to self.emit upgraded. It's complaining here because we don't have the this event, upgraded event, and also this sort of event and struct. So you need to copy it also. So copy the struct here and the event like that. So I'm going to paste it somewhere. I'll paste it below the struct storage struct, and everything will be gone. So if you don't have these three, it will just complain about the class hash first. Then it will just complain about these ones here. So you have to have these traits and some imports from Starknet, and from the core, that's the Cairo language itself, that's language server, imports 0, 0, and etc. and 0, etc. to make sure that here when it's calling the is0 method, it does not fail. And Starknet replace syscall, yeah, to help you just upgrade your contract. So let's test out this. So I'm going to just scab clean and also then scab build. So we have a new built contract. So let's deploy it. So we can't really use this one because this one didn't have that capabilities. So so this hello Starknet upgradable. So we pass in the casting file. In this case, this is the file here. Yeah, that one. And also we pass in the Sierra file like that. So declare. Okay, I'm having issues here. I think it is using old accounts, something like that. Let me just reload this thing. Disconnected. Okay, it just disconnected. Oh yeah, it's done. So we run it again with the old existing information. Hello Starknet upgradable, like that. Then we pass in the casting file, and also we pass in the contract class, then we declare. So this is going to do a declaration, taking a bit because this is sort of a new thing. Okay, no, it has not really connected. Reload to for it. So, yeah, this part of the things, as I said, the beta version is having some small issues and bugs here and there. Something like that. I think the button should be able to do that. So I hit deploy. So this one is going to deploy the contract. I'm not sure why it's taking its time to do that. Yeah, nice. Now we have our contract deployed. Now if we look at our contract here, we see it. So we just click. The good thing, you can look at the time. This is the recent one. So there we have now a few more functions. And if you look here now, it has separated the functions based on the interfaces. So the Hello Starknet interface and upgradable contract interface or traits. So you can now quickly call the upgrade function and the version function. So currently, let's just call the version function. So currently it's saying 1. So that's the current version. Let's look at it. So it's reading here 1. So that's what we have currently. But let's say we wanted to upgrade this contract to another version. So what happens? What you need to do is you come here and just change maybe the version to 2. Because this thing is sort of fixed or static, sometimes you might also need to just have the version maybe in your storage like this. Maybe you can start with version 1. No. Here it should be a U8, not version 1. So it's the member and the type. Then when you are maybe upgrading, you just do something like self dot version dot write self dot version dot read. So you read the old version, increment it by 1, then write it to the version object. Then here, instead of returning 2, maybe you can return self.version.read. So let me just write it, but for this case, I'm going to have it like fixed like that for now, version.read like that. So that's what you can do. So it's going to return a U8. So for this case, we are just going to return 2. Otherwise, this could have worked very well. But yeah, we just want to see upgradability functionality. So I'm going to scab clean and scab build again. So it's going to do the same thing. Now you are going to come back to your Devnet here and hit deploy. So you can call this maybe Hello Starknet. But here you just select the files. For this case, we have not added the functionality of upgradability, but that's the next thing. So when upgrading, you only need to declare your contract to receive a new class hash. So like a new ID pointing to a given source code somewhere. So that class hash. So you only need to declare. That's why I've said we don't have a proper thing for that. So now that we have declared, we don't need to deploy. We just need to get the class hash. So you will notice here it will give you back the transaction hash because it's a new contract, or the source code is different, and class hash. So let's copy the class hash. So copy, Control C, and we are going to use this to upgrade our contract. So how do we upgrade it? Just go to your contracts, find your contract that you want to upgrade, click on the upgrade function and paste the new class hash there like that. Make sure you remove the quotes, but that is if you are going to copy from the DevTools. Otherwise, there will be an implementation for that. Just declaring. Now that we have called this function, it has returned a given transaction hash. Yeah, also currently we don't have receipts for these transaction hashes. They'll also be somewhere. So now that we have upgraded our contract, we can look at the version. Let's just query this. We expect to get 2 Now it has upgraded our contract. We didn't really deploy a new contract, but just upgraded the old contract. That's one thing that Starknet has that I don't think whether the rest of the chains really have it as simple as it is. Just having something replacing the class hash and you are done. And the source code, in fact, I believe, or the rest of the information will remain the same. Yep, this is the problem. The information is gone south, but the contract address remained the same. The data disappeared. So I think there's an implementation for that is migrating the data from the old contract to the new contract. I have not really worked on that or done that before, so I can't really explain it further. So, but that's it. If you want to maintain the same contract address but rather update the contract itself, then doing something like that can help much. No, I think I got this one wrong. Yeah, I think I didn't do the right thing here. Just a moment, just recall something. I must have upgraded the wrong contract. I'm not sure. Yep, let me look at the functions here. So this function, this contract has been deployed. This is like a new deployment with the upgradability functionality, of which is not the thing that we expected. Yeah, I think I did it wrong. That's why the data was not there. Sorry for that. Yeah, we needed to upgrade a different contract. Is it this one? No, it's this one. We upgraded it before we were having data. I'm not sure. Yeah, let's just have a different contract. But yeah, that's the thing. Upgrading, no, it doesn't delete the data. Or does it? No, it doesn't. I think I must have missed it because we had no calls for this contract that we upgraded. We had 0 calls before, so that's why it sort of did that. Anyway, the only call we had is the first call of version. We had not really done any other calls for increasing or decreasing. Yeah, data remains. I think I seen that one. Any other questions so far up to that specific point? We have covered a lot, including upgradability. Yeah, so the last part is Devnet, no, testnet and mainnet. So the StarkDeployer has that functionality or offers that ability for you to deploy your contract direct to testnet and Devnet. But for this case, you need to use your Bravos wallet. You can't really use your agent wallet. Agent wallet gave us problems trying to deploy contracts, so we only landed onto Bravos. So to use Bravos, just connect your wallet first. There, connect your Bravos wallet, then hit deploy, and the contract that we're going to deploy in this case is called Hello Starknet. No, yep, Hello Starknet. So let's use the upgradable one here now. And here I'm going to select the custom file and also select the Sierra file and then hit deploy. I'm not sure whether this one is going to work. Yeah, so this one will work in a fun way. I only have deploy function or button here, so I'll just hit declare there. So this one is going to declare our contract on testnet. Then it should execute deploy. This is another thing that we have not looked into further because it's hiding it somewhere there. You might not notice it. So I might be forced to hit it again for it to bring me the deploy. So declare failed and all those stuff. So I'll hit that one and hit deploy. Yeah, so it's going to deploy and it's going to load the deployment here. So we give it a moment as it is finishing. As it finished. Yeah, it has finished deploying. Yeah, so we have our contract here. The same way we were interacting with it or the offline way. Now in interacting, you can either use agent or Bravos. There's no problem. So for this case, let's just sort of call the increase balance. And the interface here it looks slightly different a bit. So here we are going to increase balance by 10 and make that call. We sign the call That's one thing. Then we can get the balance. Just click make call. Okay, this is another thing. So in Devnet, you can just write and immediately read, but on testnet or mainnet, that doesn't happen immediately. So you have to give it a few seconds, like 6 seconds, for it to be able to completely do that, or 10 seconds. Then it can be able to give you now the value. So there we have our value 10. So we can also increase the value by 2, we have, or by even 29, we have our 39. Make the call, we sign. So another advantage of this platform is that let's say you wanted to go to testnet, you don't have a UI for your application for now. How can you be able to get a UI quickly? This is easier to deal with. More functions, more features will be added, i.e. just importing a contract based on a contract address, getting all the list of the information, that is the functions, the interfaces, etc., etc. So you don't have to really worry about, I'm getting some comma here, I don't know what that comma means. So we have 39 there. So that's the new value. So let's look at the version and try to, so this version is version 2. So let's upgrade this one to version 3 and see whether it will work as expected. That is without really deleting the value. That's the information. So we have that one there, and we are going to rebuild it. Don't know whether, oh, this one will give us the class hash, in fact. So let's just go back to, let me go back to the home page. I'm going to hit deploy here, and I'm going to say hello Starknet. So I can do here v3 like this, select the custom file and also select the Sierra file and hit deploy. So it's going to give us a new stuff for declaring. So I just need to copy the class hash here before I hit declare. This class hash is calculated beforehand, so you don't have to wait the transaction to be signed online or on chain for you to get the class hash. You can just get it here quickly. It's calculated beforehand, or based on the custom and based on the Sierra file. I think, is it Sierra? One of those. So I have that one. So how do I upgrade this? Just go to your contract itself, click on interact, connect any of your wallets, do the password, then hit the upgrade function, pass in the new class hash that you want to upgrade with, and make the call. Invalid type expected array received null path. Yeah, so maybe we are getting this somehow wrong. I'm not sure why this is happening. Let me just reload the page, maybe, or maybe it's agent itself giving us problems. Yeah, you have seen that's the next problem, agent problematic. So you can cram that one. Okay, Bravo's account implementation sort of allows for these things, but the agent account implementation does not allow account okay, for now, I don't know, I'm not sure. It does not allow contract declaration and things that do with the contract declaration upgradability. It does not work with it. Yes. So let's look at the version. I don't know whether it has updated this one. Yeah, we have version 3. Let's look at the balance, see whether it's still 39. Yeah, it has confirmed. Data does not disappear. You only need to change the class hash and the data remains the same and everything works as expected. Yep. So that's for testnet. Same works with the mainnet. So when you are using this platform, don't use agent in declaring or deploying your contracts. Kindly use Bravos. So for mainnet, just click there, switch to mainnet, and proceed to deploy. So let me see. I'm not sure whether this will work. I've not really tested out. I don't know whether I even have enough tokens there. Okay, my Bravos really has nothing, so it can't really help with that. Yep, maybe I try with Agent X. So let me disconnect, connect with Agent X. but I'm not sure whether it will declare or even deploy. Believe my agent X should be having some. Yeah, it has a few tokens there. Yeah, this one fails by default. It will bring this error called failed to declare error timeout. I don't know why it will bring a timeout error. Yeah, we tried this with different times. That's the time to wait for transactions, but it didn't seem to work for agent. So we opted to just go with what works. That's Bravos. So that's it. I don't know whether somebody has a question or something to add, etc., something to comment on. I'll invite all those. Okay, I believe then we are good to go. Then we can call this a day. I don't know whether Ochieng is still in the call.
Yeah, I am actually. Yeah, amazing work. Thank you for putting in 2 hours for the presentation. So the video we did last time had issues. We had audio issues, so yeah, that did make it. But we got some new software, so I believe they should be good. So you're also recording as well,
yeah? Yeah, I think my recording is doing good here. Yeah.
Yeah, I'm using the same OBS.
Yeah.
Yeah, same. So yeah, I think we should be good. All right, so I think that's everyone. Good night and thank you for meeting for this call. I'll catch you on the next one.